Now, with these preparations, we are ready to give the analogy to Haar's original idea of using sets as approximates for Haar measures, as introduced by Weil. So, analogous to Haar's original idea, Weil's proof will fix an F0 in CC plus of G. And remember, Haar's proof fixed a E0, a set. And we put a quotient F column phi over F0 column phi. And we denote this quotient by I sub phi of F for F phi in CC plus of G. And remember, this is an analogy to Haar's original idea of using this quotient. Now, by the lemma 1 above, we see that I sub phi of F is left invariant. What does this mean? This means I sub phi applied to L sub x of F is equal to I sub phi applied to F for any x in G. And this is essentially due to the part A of our lemma 1. And we notice that I sub phi looks like a positive linear functional, except that this I sub phi is only subadditive. Remember, this is again by our lemma 1. The properties B and C will correspond to the subadditivity of I sub phi. And by the property D of our lemma 1, we can immediately see that I sub phi of F is bounded above by F column F0, while it is bounded below by 1 over F0 column F. And our next goal will be to show that I sub phi in here will play the same role as this quotient in Haar's original idea of proof using sets, which will approximate the Haar measure. Well, in our situation, this subadditive functional will approximate a positive linear functional. Why is a positive linear functional so important and so good? Do you remember? Here we care about positive linear functional because a positive linear functional will provide us with a Radon measure by the Riesz Representation theorem from real analysis. Let me carefully write this down. Our next goal is to show that I sub phi can be used to approximate a positive linear functional, denoted I, which with the help of Riesz Representation theorem. We'll generate the Haar measure as desired. And this is the core idea in Weil's proof of the existence of Haar measures, which is essentially a generalization or analogy to Haar's original idea of using sets. And now we're going to carry out this idea carefully.